An AI task can have a tiny model bill and still cost more than the work it was meant to replace. Token prices measure input and output processed by a model. They do not include data preparation, software integration, human review, failed actions, compliance, or the hours when reserved infrastructure sits idle. The correct comparison is total cost per accepted outcome, not cost per million tokens. Start with model inference. Add retrieval, storage, orchestration, monitoring, security, and vendor support. Then add human time for defining the task, checking uncertain cases, and correcting errors. Finally, add the cost of a wrong outcome, rework, refunds, missed sales, or regulatory exposure. Automation wins when the combined system produces enough correct outcomes at sufficient volume. A low unit price is only the first input. Model prices can change quickly and vary by capability, context length, processing tier, and cached input. That makes a static cost estimate fragile. A cheaper model may need more retries or more human review. A stronger model may cost more per token but reduce downstream failures. Measure the workflow with real traffic. Tokens per case, acceptance rate, latency, review minutes, escalation rate, and cost of corrections. A demonstration becomes useful only after it connects to reliable data and existing systems. Permissions, schemas, identity, logging, evaluation, fallbacks, and incident response all require engineering. These are not one-time details. Data and models drift, APIs change, and business rules evolve. The cost curve, therefore, includes ongoing maintenance. A prototype that saves 10 minutes in a controlled test may create more work when exceptions meet production. NIST notes that human roles and responsibilities must be clearly defined, and that some systems specifically require oversight. Review is not automatically safe or cheap. A reviewer can become overconfident, miss subtle errors, or spend more time reconstructing context than doing the original task. Design the escalation boundary. Which cases pass automatically, which need review, who can override, and how decisions are recorded. Wrong internal summary and a wrong medical or financial decision do not have the same cost. Risk changes the economic break-even point. High-impact workflows need stronger evaluation, monitoring, access controls, and sometimes mandatory human judgment. Those safeguards add expense, but omitting them can produce much larger losses. The relevant error metric is expected harm, probability multiplied by consequence, not an average accuracy score alone. Reserved GPUs, enterprise contracts, and engineering teams are fixed or semi-fixed costs. If usage is low, each accepted task absorbs a large share. At high volume, the same system may become economical. This is why pilots can mislead in both directions. A small pilot can look cheap because shared labor is ignored, or expensive because infrastructure is underused. Build a cost curve across realistic demand levels. Automation is strongest in repeatable high-volume tasks with measurable outputs, clean data, and inexpensive correction. It is weaker when cases are rare, context is tacit, or errors are costly. Hybrid workflows can be superior. AI drafts or classifies, while people handle ambiguous cases. The goal is not to remove every human. It is to allocate attention where human judgment changes the outcome. Ask whether savings include integration and maintenance. Compare cost per accepted outcome, not generated output. Report review minutes, escalation rates, and the cost of errors. Model multiple utilization levels. State which model and price date were used. Finally, separate headcount avoided from cash actually saved. A workflow can increase capacity without reducing payroll, and that may still be valuable, but it is a different claim. AI economics live in the workflow around the model. Tokens matter, but so do data, integration, oversight, error handling, and utilization. The right question is not whether AI is cheaper than a person in the abstract. It is whether a defined system produces a reliable outcome at lower total cost and acceptable risk. Follow every line from prompt to accepted result. The hidden bill sits between those 2 points.